Okay, in this video, we're just going to work our way through some of the answers for the Pupil booklet for Unit 3, specifically key areas 1 and 2 today. I know some people had found bits of this tricky, and some of the questions aren't particularly well written, so we'll just talk our way through that. So hopefully we understood that the structure of the central nervous system and the peripheral nervous system, as it's given here. The central nervous system is just the brain and the spinal cord, so what runs centrally down the middle of the body. The peripheral nervous system comes off the central nervous system, so that's all the other nerves in our body. So it shows here that's separated into the somatic, so mostly the voluntary nervous system, although it has some applications in our reflexes as well. So the peripheral nervous system has the somatic, which is our sensory neurons, so bringing information from our sensory receptors to the brain, and our motor neurons, so bringing information from the brain down to the effectors, or muscles, or glands, things like that. We have the autonomic nervous system, which is the other branch of the peripheral. The sympathetic prepares your body for action, so it's what we tend to think of as our flight response. So it would do things, we'll talk about it later on in the video, but prepare you for action, and the parasympathetic tends to be a calming response. So the somatic, we've just talked about, it controls the body's skeletal muscles. It's composed of sensory and motor. So using page 203 in the textbook, we've explained the function of the motor and sensory neurons. The sensory is carrying the information from the body's senses to the brain, and the motor carrying instructions from the brain to the body. Most of the movements made are voluntary, however, as we've stated, involuntary reflex actions are also included. The difference between voluntary and involuntary. Voluntary actions are ones that happen due to conscious control by the individual. So you choose to move your arm, you choose to speak, you choose to do these kind of things. Involuntary actions tend to happen without your awareness or conscious control. So things like your breathing, unless you think about it, as you probably are just now, your breathing will just happen because of your medulla in your brainstem. Things like blood vessels will vasodilate and vasoconstrict. This is controlled by the brain, but you don't need conscious control of this. So we've separated the autonomic, which are the involuntary actions, down into the sympathetic and parasympathetic. So these are antagonistic at all times. Both the sympathetic and parasympathetic nerves are working on your heart. Sympathetic is trying to increase your heart rate, parasympathetic is trying to decrease it. They are antagonistic, so the bad guy in most books and films is the antagonist. So these are working against each other, and it's just whichever one is receiving more nerve impulses at any one time. So if your brain is producing more sympathetic impulses to your heart, the heartbeat will go up, even though there are some parasympathetic signals. So if all of your sympathetic responses were activated, you would have an increased heart rate, breathing rate, perspiration rate, blood flow to your muscles, and adrenaline production. You would decrease the blood flow to the skin, blood flow to the gut, and peristalsis, so the movement of food and fluids through the gut. And it is the opposite way around here. The sympathetic system is normally active when you are excited, so as we stated before, flight or fight. Some of the symptoms you might have is a high heart rate, high respiratory rate, and decreased production of intestinal secretions. So this is just a summary of the previous table. The three body symptoms that you would indicate for parasympathetic, so again, it's just the opposite of the ones above. We're then moving into looking at converging, diverging, and reverberating neural pathways. So convergence is multiple different neurons are firing impulses down, and these meet with a single neuron at what's called a synapse. So the gap, we talk about it in a future section, but there's a gap between these neurons and the cell body of this neuron, and this is a synapse. So all of these are sending complementary signals down to the cell body here, and they're being amplified and then sent down. This is quite important in our sensory pathways. If you imagine a very soft touch that your body might be stimulated by on your fingertips, that might not be enough for your body to recognize it as a stimulus. So all of those soft touch stimuli that you feel on your fingertips are summed together through summation, is the term, and these converge into one neuron like this. Again, it's also important in things like the rods and cones in your eye. Divergence is the opposite, so when a single cell body is sending information out, and again, it joins its synapses to these neurons here. So a single command or information can be sent out to multiple different effectors at once. So this is often used in our motor neural pathways. So you can imagine it would be useful in fine motor control. If you want to play the violin, for example, you need multiple muscle systems working at the same time, doing the same movement. And it's easier, rather than having to organize all of them at the same time, just to send one signal down and all the muscles get it at the same time. So this is divergent neural pathways. Reverberation is very important in things like breathing. So there's some commands that your body wants to give to the effectors that is always wanting to give that command. So for example, in breathing, you can imagine that as a stimulus that is a command that your body is going to want to keep sending to your lungs. So to decrease the number of impulses your brain needs to send, the impulse is sent the first time, it's sent down through a series of neurons, and it gets the effector. Midway to the effector, there's actually a branch off the neural pathway, and it comes round and feeds back into an earlier part of the loop. This amplifies that signal, so a single neural impulse can become 4 or 5 because there's this reverberation back around the pathway. This means that your brain needs to send fewer nerve impulses to achieve the same large stimulus. So that was key area 1, so 3.1. 3.2, we'll group it together, is the cerebral cortex. This all looks very, very complicated, and a lot of it is just so that you have something to do in the booklet. You actually do not need to know where different functions happen in the brain. You need to know that there is something called localization of function. So you need to know that there are areas of the brain that are specialized for specific functions, but you don't at all need to know where they are, or examples really of what they do. You need to know that you have sensory areas of the brain, so areas that are responsible for receiving information from your sensory receptors. You need to know that those sensory areas receive the information but don't process it, that there are associated areas attached to each of those. So the area that receives your auditory information, so hearing words, receives it, but then there is an association area which it passes it to actually process information. You don't, as I've said, you don't need to know where that is. Similarly, with motor pathways, you've got an associated area, which makes the decisions and crafts the motor impulses that can be sent out. And then you've got the primary motor area that sends that out. So again, you don't need to know where they are. You just need to know there's an association area that decides which muscle groups are going to be affected. And then there's an area, the motor area, which sends that out. So all of this was just an example. A lot of people got very, very confused with this. It was trying to give the idea that multiple different parts of the brain would be involved in what is actually quite a simple pathway. So if you wanted to listen and understand something, you would need to use the part of the brain which heard the words because you're listening, and then that information would need to be understood. So you'd hear the words, and then that information would be passed to the area that understands it. So that is E and then D. To read something, you would see the words. So the visual stimuli would come into your brain. It would then move to F. So there's part of your brain that is just for understanding written words. And then if you're reading it, it would move to D. So sorry, you see it, you recognize it, and then you understand it. If you need to read aloud, That needs to happen. You need to see it, recognize it, understand it. You then need to move that information to a sound pattern so that you can communicate it. You need to move that information to preparing the lips and the muscles of the face to speak those words, and then you need to control the muscles and actually do the effect. So as I said, you don't need to know which parts of the brain do each of these things. This was just a task and activity which confused an awful lot of people, which was to get the idea that different parts of the brain would need to work in concert to accomplish quite simple tasks. Again, the next bit, the examples tend to make it seem a lot more complicated than it is. You were supposed to understand that the right-hand side of the body was controlled by the left hemisphere of the brain, that the left side of the body is controlled by the right hemisphere of the brain, that there is a physical connection that the right eye is wired into, if you excuse the parlance, the left side of the brain, and the left eye is wired into, through the nerve, the right side of the brain. So sensory information from the left visual field, so everything the left eye can see, goes into the right hemisphere, and same, the right visual field goes into the left hemisphere. That for us, if we close our left eye and look at a word with our right eye, so for example, I'm close my left eye, I can just about without my glasses read where it says right visual field. That information goes in through my right eye to the left side of the brain. Now, because of localization of function, the fact that different parts of the brain do different jobs, I can understand that. The left hand side of my brain can understand information that comes in from the right hand side. Whereas if I close my right eye and look with my left eye, where it says here left visual field, that information goes into the right hemisphere. And the right hemisphere cannot do anything with that. Now, I'm not lying, I genuinely have closed my eyes and looked at this. So how am I able to understand it? It's because even though the information has gone into the right hand side, it crosses over the hemispheres from the right side to the left side through what's called the corpus callosum. Now, because I have an intact corpus callosum, it's fine. I can be blinded in one eye and still have the ability to read words. It'd be quite worrying, actually, in a world where if you're blinded in your right eye, you could no longer understand words. If I were to cut through the middle of the corpus callosum, though, if I closed my right eye, I wouldn't be able to understand any words. I'd be able to kind of identify the shapes of the letters and words, but it'd be as if I was reading hieroglyphics, which I do not read. Similarly, if you use your left hand to feel objects and to move objects, your right side of your hemisphere can't understand that because it is spatial and construction. You don't need to really understand this in a lot of depth, just understanding that each side of the body can control the opposite side. If you're to any question that will ask you to use the fact that the left hemisphere can do speech and writing and the right hand side does motor and construction, they will tell you that in the question. So it's actually not part of the course to know that. And these ones here are questions. This one here makes a lot of sense. This one here confused a lot of people, so we'll just skip over that. I think that's the end of the PowerPoint. Hopefully that makes a little bit more sense. Again, if there's anything that doesn't make sense, please go back, look at the video, look at the other summary video I've made, and of course, if none of that helps, just ask.